twins, Noah and Joa, have a zoo that travels around the MPI system, showing the different animals from around the galaxy. Since they don't want to harm the animals, the twins have designed a tractor beam that gently plucks the animals and sends them to the animal sanctuary on their mothership, the Ark. The twins love quadratic equations. Being twins, Noah and Joa have a natural love for the number 2, and since quadratic functions have a degree of 2, they designed their spaceship's tractor beam by graphing quadratic functions. The twins need to diversify their collection of animals. They've come to planet Nyleesh in search of one small and one large animal to add to their collection. Let's take a closer look at how the tractor beam works. The quadratic function graph that the twins use to collect the animals has a negative a value. You might remember from math class that when quadratic functions have negative a values, the graph, a parabola, opens downwards. The closer the a value is to 0, the wider the parabola becomes. Continuing with the a coefficient, and the value of a is positive, the graph of the parabola opens upwards. The behavior of the graph is the same. The further away the absolute value is from 0, the thinner the parabola becomes. Look what happens when a equals 0. Since multiplying anything by 0 equals 0, we're left with f of x equals bx plus c, which is just a linear function. The coefficient b alters the position of the vertex. So, how do you find the vertex? When given a quadratic function, you can get the x-coordinate of the vertex by using the following equation. X equals negative b over 2a. That's great, but if we want to graph this point, we need a y-coordinate as well. To find the y-coordinate of the vertex, we simply have to plug in our solution for the x value into the standard form equation, and now we have our y-coordinate. Let's plug in negative 3 for b, 1 for a, and 0 for c. The x-coordinate of the vertex is negative b over 2a, so negative negative 3 over 2 times 1, which equals 3 over 2. Plugging this back into our equation, f of 3 over 2 equals x squared minus 3x. We get f of x equals negative 9 over 4. Notice how the position of the vertex changes. Let's take a look at some other values of b. The sign of the quadratic coefficient a and the sign of b also help to determine the direction of the shift. The axis of symmetry moves to the right of the origin if the coefficients a and b have different signs. The axis of symmetry moves to the left if the coefficients a and b have the same sign. The coefficient c simply raises and lowers the parabola's vertex. The twins spot a small animal. Oh, wow! It's a weebo! The twins need an a value to just cover it. No one knows that the bigger the absolute value of the coefficient a, the thinner the parabola. And, since the weebo is below the spaceship, the a value should be negative as well. Perfect! Oh no! The weebo's making a run for the bushes! The twins have to change the value of the b coefficient so that the signs of a and b have different signs for the vertex to move to the right. Since the tractor beam needs to be concentrated on the animal, Noah adjusts the c value to negative 3 to place the tractor beam right above the weebo. Great! One down and one to go. Noah and Joa spot a large animal they've never seen before. It's a ginormous manto! Noah sets the tractor beam value for the a coefficient to a wide setting, negative 0.1. What a relief! It's just enough to cover the large animal. After bringing the animals back to the ship, Joa's in charge of sending them to the Ark safely. Joa reverses the tractor beam by setting the A value to a positive number. The Weebo goes to the mothership with no problems. People will be excited to see these exotic creatures. Joa is set to raise the Manto to the Ark. He sets the A coefficient value to 0.1 and maybe the twins have bitten off more than they can chew.